Okay, so this experiment is the experiment to measure the relative molecular mass of a volatile liquid using a conical flask. So you should have gotten your own results here for the mass of the empty flask and then the mass of the empty flask, the mass of the empty flask with the condensed liquid after cooling. So that's the mass after the experiment is completed. The mass of condensed liquid then, all you have to do is take these two numbers that you've gotten away from each other. And I got around 1.31 grams for this one. The atmospheric pressure then you measured, and you should have a different number here possibly. I got 1.2 by 10 to the 5 pascals. And if you have a machine that measures kilopascals, just convert it into pascals. Temperature of vapor in the flask, well, the boiling water was 100 degrees Celsius, so that means the vapor inside the flask is also 100 degrees Celsius. The volume of the flask equals the volume of the vapor. So when you were doing the experiment, you would have filled up the flask completely up to the very top with water and measured how much that actually contains using a graduated cylinder. So this one here is 332. You might have a slightly different answer. So you just make sure the conversions are correct. So we're going to put it into pascals. Mine's already in pascals. So I'm going to write 1.2 by 10 to the 5 pascals there. Volume in meters cubed. So you can see that mine is in centimeters cubed. And all you have to do is you have to take the 332 and put by 10 to the 6 after it. But I have a little conversion that I just like to remember. So my conversion is 1 meter cubed is equal to 1,000 liters. And you can say 1 liter is equal to 0.001 meters cubed. Okay, so there are the conversions. Now I have 332 centimeters cubed. That is 0.332 liters. So if I go 0.332 liters here, multiply 1 by 0.332, I'll get 0.332. Multiply 0.001 by 0.332, I'm going to get 0.000332 meters cubed. And that's just using this conversion right here. Okay, multiplying both sides by the 0.332. Now, if I want to bring that back, see the decimal point? 1, 2, 3, 4, 5, 6. I'll end up with 332 by 10 to the minus 6 meters cubed, which is that rule. So change centimeters cubed to meters cubed, you just add by 10 to the minus 6 at the end of it. Okay, so I'm going to write that in. Then the temperature in Kelvin, so it was 100 degrees Celsius. And then to change to Kelvin, you just add on the plus 273. So it's 100 plus 273 equals 373 Kelvin. And the ideal gas constant is 8.31. Okay, so we have those pieces of information now. And it's asking us to find the number of moles and the relative molecular mass of the liquid. Okay, so I'm just going to do the relative molecular mass first of all. And we can do that by comparing the current situation here of the gas with this pressure, volume, and temperature that we have against the standard temperature and pressure. So we'll fill this in with the numbers that we have. The volume, I'm just going to leave it as 332 centimeters cubed. This formula here doesn't matter what the units are as long as they're the same. So if it's pascals this side, it has to be pascals this side. If it's centimeters cubed this side, it has to be centimeters cubed this side. And the temperature always has to be in Kelvin. Okay, so you can see I'm only missing the volume. This is the standard the pressure at standard temperature and pressure, 1 by 10 to the 5 pascals, and then it's 273. So you're supposed to know that that is the pressure and temperature at standard temperature and pressure, that point. So with a bit of rearranging, you'll find that the volume is 291.59 centimeters cubed. That makes sense because what we've done, we've gone from 100 degrees Celsius down to 0 degrees Celsius. So there's been a decrease in temperature, which means we'd expect a decrease in the volume as well, because volume and temperature are directly proportional. So that makes sense. Okay, now to find the relative molecular mass, I'm just going to write this in. 1 mole of gas at standard temperature and pressure, takes up 22,400 centimeters cubed of volume. Now we have at standard temperature and pressure, it takes up 291.59 centimeters cubed. Okay, so it's clearly not a full mole. And we have the mass of the gas still. It's up here, what you measured up here, 1.31. That's the mass of the condensed liquid, and it's also the mass of the gas. So there's no loss in the mass there. Grams. Okay. So I want to find out the relative molecular mass. I know that this amount of volume of the gas links with this amount of grams, and the relative molecular mass is how much it would be if it was 1 mole of the gas, which is 22,400 centimeters cubed. So what I'm going to do is I'm going to break it down to 1 centimeter cubed and then build it up to the 22,400. So to get 1 on this side, I have to divide this number by itself. 291.59 divided by 291.59 is 1. And if I do that to this side, I have to divide this side also by that number. So now 1 centimeters cubed of the gas would equal this amount of grams. So you can see it's smaller, much smaller. Now I'm going to build it up to the 22,400 centimeters cubed, which would give me what 1 mole would weigh. So that becomes 1.31 times 22,400, because I've multiplied both sides by 22,400. And I'll find out that 1 mole of gas has a mass of 100.6 grams. So that is the relative molecular mass of my gas. So I have that section up here done. Now moving on to finding the number of moles of the gas. Okay, I'll do that on the next page. I'll just do it here actually. Okay, the number of moles. So I need to use this formula for this equation. And you're going to make sure that these units now, this is slightly different. So these units have to be in pascals, the volume has to be in meters cubed, temperature is in Kelvin, and R is given to you. So we have those done. Volume, N, then your constant, and your temperature is 373. So the only thing that you're missing there is N. Once you've brought these two numbers over and divided it into this, you'll find out that N, for my one anyway, is 0.129 moles. Okay, so that's it. So the only thing is With this one, you need to make sure that the units are incorrect, the correct units are used, so pascals, meters cubed, and Kelvin. Okay, and that's it.